Okay, so I have my data here, and I have these two files, very important, the patch files, which is fixing the error in the package. So we need to install our packages. In the meantime, I can try to set my working directory. Okay. I'll need wave slim. We'll use it for decompositions. And we'll need color space. Color space is what will give us the heat maps. So we do color space as well. Comment down. Remember that for this is frequency domain. We don't need the time we don't need the date column. We don't need it. We'll change it to a time series, but without dates. So we don't need that date column. So it doesn't matter how your date column is formatted. We don't need it. But you may need it for plotting, for the descriptive part of your work. First, let's load our packages and see. Yeah, this is the data. Okay, so if you look at this line of code, look at the dimension. The dimension of the data is 6 columns. The first column is date. We don't need that, so we want to remove it. So you can, this line means I want the second column to the last column. So I'll put this one to be 6, and that removes the date for me. See that the date is gone, and we have 5 columns now. Okay. Now, for the decomposition to work, we need the data or the series to be time series. We know from where we are bringing the data from, it's a time series. But R doesn't know that it's a time series. And since we are not using the date, we need to tell R that this data is a time series before we can use it in our wavelet method. If you look at the manual, it says the series should be a time series. And this TS is the function that will change the data from the data frame that it is now into time series. So if I if I do the class, if I look at the class of GC, it's a data frame. But if I run this line here, now I come and check the class of GC.T, this MTS, TS, or matrix, any one of them. Okay. So we need that. If you don't change it to series, it will not work. Okay, now we are setting the parameters for this work. Our filter, we choose filter of length 8. You can try 5 if it works fine, but 8 usually works. But for the scales, let's choose. Let's go into Excel and see how many scales we can choose for this. And I think from my experience, if you choose a higher scale, it will bring it down for you and choose the one that is applicable. So it's a log of 200 to so 7. I think we can deal with only 7 scales. However, so let's keep that one in mind, 7, but let's use 9. Then see what happens. Okay, so now that we are here, we know, let me see if the names will come. GC.T. No, it will not come, comes for data frame, but we know we look at the head, you can always get to know which column is which. Okay, so here what we are going to do is that we want to decompose them one by one. We want to decompose a series, look at how they are. If you want to use them someday for something else, we'll keep them for that purpose. So let's try to decompose. And we say this is a real valued wavelet, so we should see real valued transformation. Okay, so let's look at this. This means that we are doing maximum overlap discrete wavelet transform. So MODWT, the data frame. Now is the time series, and we want the first column here. First column. So first column is PR, and we have specified our filter and scale already. Did I run these lines? Random, probably. So what we can do is change the name, maybe PR here. PR. Because that's what we want and what we want. Okay. If everything checks out, this code shouldn't give us any problem. Okay, you see the error message. So, and that is being caused by the length J, J9. So let's reduce.
The 9 is too much, yeah.
Yes, so let's reduce J to 7 and do it again. See that we don't have any problems. Then we can look at the transformation like this. Okay, so as you are going through, look at so we have D2, that's the second scale. We have D1, that's the first. Let's see how many we have. D3, D4. How many? D5, D6. We have 7, right?
Okay.
D7, where are you? Okay, so even with that,
6.
It gave us 6 because 7 is too much. Now, this is what happens. If we had given, for example, 5, it will give us D5 and S5. 1 is the scaling factor, the long term or the further wavelet. But if we choose a number of scales that exhaust all the components, the decomposition, then we will not have a scaling factor. Then we'll choose the last one as the scaling factor. Yeah. Okay. So this is important. We check how many we have. So we have D6. Okay. Because if we want to save this output, we need to know how many scales there are so we can pick them. Okay. And if you look at the class, it's MODWT. It's not a data frame. There's no data frame for you to just write to CSV. And for that reason, you want to bind it and make it a data frame so that we can write it to CSV. Okay, so our decomposition is PR_MODWT. So I need to change this one. So this is it. I go into PRD, I go into this and I choose the scales. The scales were D1. And I do that with the $sign. So it's PR_. PR goes up to 6, right? PR, and then PR. Okay. So let me give it a different name here. Maybe P, doesn't matter. If I run this, then I make it a data frame or something that we can write to CSV. Let me look at the class here because I've changed variable. It's a matrix or an array, and we can write that into. See that it looks different now. So it's a matrix or an array, which is maybe the same as a T series. So if I write this, let me row.names, right? But the express now. So if I make something, you can drop in. Great. So this is in our working direction. What name did we PR_MODWT. So this is it. So we know, you know that this is the decomposition for CPI inflation. And because it didn't give headings for this, these are defaults. You can change them to whatever you want. And you can use it for anything that you prefer to use it for. So we can choose another variable and decompose. So choose one for us. Let's choose another one, another variable, ER. ER is 1, 2, 3, 1, 2, 3, third column.
Yeah.
Okay, so in that case, just modify this one. So ER is third column, so I'll just change it to 3. And I'll change this to ER, and I can decompose. Okay. If all things being equal, they have the same length, then that should also have 6 scales. Yeah. Then I can bind it ER, 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 ER. So if I create this, then I can save it. So let me do this to be ER rather. So I should have that decomposition as well. So now, if you want to look at the relationship, you can look at V1, let's say regression, V1, which is D1 of ER and D1 of ER. And that will tell you the relation between ER and ER in the short term. So that gives you one relationship. You can do that for the rest. And you can even do that in quantile regression form. So you go deeper. You have frequency domain, quantile domain, and that will give you better understanding instead of just doing something like OLS, which nobody really cares about now, because we know the obvious weaknesses with OLS. Okay, great. Now we can start our multiple wavelets here. Okay, so you need to read this one here. Source. So source here means that since we have this file in our working directory, it's going to rely on the codes in that file to work. So you run the source here, and it will work because the file is inside our working directory. If this file is not inside the working directory, then this line will not work. Okay, so let me go back to 9 here. We know 9 is too much, but let's use that. So here, what we want is the multiple wavelet correlation, but for the bivariate case for all the variables. So, and one limitation of this particular package is this. For the bivariate, you can only take 7 variables at a time. So if you have a data with more than 7 variables, you cannot get all of them at a time for the bivariate only, not the multivariate. So for anyone with more than 7 variables, you will need to split them and look at the bivariate separately. Okay. So since we are used to WF, let me just use WF for the filter. Change that. Okay, so let's run the lines. Okay. Now here we see W2CWM2C Wavelet Correlation. Okay. This is the data frame, not the data frame, it's a time series. Okay. This is our filter, and this is number of scales. Everything else is default. Okay, so let's run this. It will not even work for us because the scales is too much. So let's reduce it to 7. I wanted to show you something. So, okay, so this is what I wanted to show you. You see that for the scales beyond which the method is picking correlations are any. So it's telling you that with the data and the algorithm, it will not go beyond scale. So 1, 2, 3, 4. It will not go beyond that. So what you will do is that now we need to go back and change it to 4 and run again so that we have a complete. Okay. So this one is clean. What you should realize that, so look at this. Look at the coefficients, for example, they will not change. If we did 7, it will keep the coefficients the same, but something happened. The same, yeah. See, the coefficients are the same; they don't change. Yeah. It's only the NAs that they are showing. So normally, what I do is, if I'm able to write it to CSV, because the matrix is not balanced, I'll choose a longer scale, get them into CSV, and then when I go there, I'll remove those NAs, and I can come back, go back to my scale and get my plots, which I'll use. Okay, watch this. This is what will usually happen. Let me show you. My screen is big and my graphics is very high, so I hardly get that error. So this is what will usually happen. When you plot this, right, you have this plot show. But what you realize that this heat map, the bar here will not show. Okay, and you have an error saying that screen graphics too large, something like that. When you have that, what you should do is that you will come here and expand the plot like this. You just expand it. Don't close it, expand it. When you expand it, you leave it there and go and run the same line again. If you run it again, then you have your full plot with the heat map, with the indicator here showing, and the error will be gone. So when you get there and you encounter that, go through this trick, it should work. Okay, a few things to look out for in this plot. Here, you see that the scale is giving you an indication of some negative correlations. Yeah, so the deep blue is negative. The highest positive is 0.67, that's red. Okay, so now look at the indications here. C1 all the way to C5, that is how you have arranged your variables in your table. So C1 is PR, C2 is I think this one will give us, yeah. So C1 is PR, C2 is CR, C3 is ER, C4 is IR, and C5 is RY. That's how you look at it. So let me annotate and see. Okay, so here is the correlation between PR and ER, C1 and C3. Okay. And realize that, so for here, so all this line is for those two. They move from 0.39 to 0.2, then they increase 0.52 and reduce at the last scale in 0.35. See some form of interplay of decoupling and recoupling in between those two variables. But C3 and C4, so that would be ER and R and IR, you see that the correlations are increasing along the way. So that's a form of integration in the long term. C2 and C3 are decoupling completely. Look at them. So credit, what was it? Credit and what? Exchange rate. So let's look at the negative ones. What is happening with them? What's unique about those variables? C1 and C2. C1 is CPI inflation and C2 is credit. They move in the opposite direction, but strong. A little bit, let's say moderate, 48% is like halfway through. And the same with C2 and C5. C2 is credit and GDP. That's basically expenditure and GDP. So they are strong, but moderate. So when looking at your variables, you should be able to see how the interpretation and the relationship makes sense. Let's see C3 and C5. Zero relationship in the short term. C3 and C5. C3 is exchange rate and GDP. Takes a while for them to start to correlate. Yeah. Yes, so this is for the bivariate. So you right click, copy as bitmap, you can save and paste in your Word. Okay, so that's for the bivariate. Now all these coefficients, you can save them into Excel and then you can present them as tables if you want in your work. And for a thesis, you may want to keep all of them. If it's a paper and you are running against space, then you can choose not to present them. So these are the correlations, all of them. And these are the ones, these ones, the top two. So you see this one, that is the ones that you need, the ones that are in the plot. Okay, let me see if I can write them to CSV. If it doesn't work, I'll increase the skills, get them in a way that I can write them, and when I go there, I can remove them. Okay, so it won't work. You see, 10 rows against 4 columns. It will not work because of this thing. So what I can do, since I already have my plot, I can make this 7 and then try to save it. Again, it doesn't work. So what will work for me? Let's see. 1, 2, 3, 4, 5, 6, 7. And this is 5. So let me do 5 by 5 and see. They don't affect the correlations anyway. Yeah, see, this one has worked. And I go into the data. So these are the correlations. I have it. I don't need the rest, and I can delete the NS. Okay, so now let's go to the multiple now. So with the multiple, there's no limit on the number of variables you can use. Whatever number of variables you have in your data, as far as I'm concerned, I haven't encountered where I'm giving a limit on the number of variables to use. I was going to do linear combinations and choose the ones with the higher R squared at each scale and show them to you. Okay, so let's see how it comes out. For consistency scale, let's change this to WF as we did the other one. Okay, so we run our filter, we run our scale, and then run our plot. Okay, this one is a problem. Okay, so Providence.
Yeah.
Are you familiar with what is the word? Singularity. In matrix.
Yeah, near singular matrix.
Yes, when you have almost
zeros.
Not exactly. Okay, when you have a very high level of correlation between the variables, you are likely to have a singular matrix. So that means you have a zero determinant, and because of that, you cannot find the inverse of the matrix. Yeah, so that is the problem we are facing here, and this is purely from the data. It's not from the code. Now, the problem is that I was going to show you another way, because the plot that comes, there's an issue with the plot. Most people don't know, so when they present it in their papers, because they don't understand the basis of the method. So normally, if I don't want to present that, then I go and use the manual code for this. And that's where I usually run into this problem, but I don't run into this problem when I'm using this, the phase codes. So that will be a problem to deal with. Okay, let me see. Let's change the scale and see. Oh, wait, the scale should be 4, right? Yeah, so let's change that and see. Oh, great. So it was the scale. Problem solved. Great. That's a relief. So this is what I was telling. I was trying to explain. So let's look at the plot. Okay, so in the short term, we have about 45%. Then we go down to about 25. So we are saying, this is what you're saying. We're saying that in the short term, the correlation between these 5 macroeconomic variables can be explained by, to the degree of 40%, by just the variables. Everything else cannot be explained in the system of those 5 variables. And that goes down to about 25 and shoots all the way to almost 80, then drops a little. So integration is high in the long term. Okay. One thing. Yes, this is what I wanted to show you. Now you see this. the variable names here. The variable names there, you cannot interpret them because they are portraying something that is actually not true. They are portraying potential leak and lag. So the variable names on the x-axis, you should ignore them because they are not portraying something right. I will show you why. Because when you decompose, they add an extra scale to it. And that extra scale will pick up another variable. So it distorts the order of the variable in the table. And I'm going to show you that one shortly. Okay. So we can explain this plot, ignoring the labels at the bottom. So the safe way is do not interpret those ones. Just leave them if you don't have a way of removing them. But you can Photoshop and remove just the names. Everything else is correct. Otherwise, what you can do is to extract the coefficients, which we are going to see shortly, and plot this in Excel. It's just simple. You put them in the columns and plots. It will show exactly as it is here. Or there's a manual code that will plot. You go through the decompositions one by one, you transform them, do all of that. And then by the time you finish and get this plot, the names will not be there. Okay. But apart from the labels down here, everything is right. And most people don't even know anyway. So only a few of us who know what is wrong with that. Okay, so that's for the wavelet multiple correlation. So now let's go to the cross. Oh, let's save the output first. So let me explain this one a bit. See, you see max R. This is the localizations. We had how many scales? 4. And so, but if you come here, you see 1, 2, 3, 4, 5. Okay, and you see that the highest correlation was about 80%. Where is it? Yeah. Where is it? So it's almost 80%. This is the correlation. Let me bring the annotate again. So this is the correlations. So these are the correlations. And this is the lower boundary. This is the upper boundary. So you realize that this last scale is not part. You don't need it. And it's showing almost perfect correlation, which is not the case, right? Now, each one here, this one is for the first scale, this is for the second scale, third scale, fourth scale, and this is supposed to be for the fifth scale, which we don't need. And each one of these numbers is telling us of the location in the table of the variables, okay? Each one of the numbers is telling us of the location of the variables in the data. So 3 is, I think, ER, 1 is PR, 3 again is, and 4, you know. So, and those are the ones represented in the plot that you saw at the bottom. So you have to ignore the plot, those names there, because this large scale is distorting the arrangement. That's why I say you ignore that one. So what you can do is, since you can plot these correlations itself here, you can just plot them. Let me see, come on, WMC, yeah. So this is it. You have everything you need. You can just plot them in Excel, and you have the same plot without having to deal with this. So this is not needed. Yeah, and this is your correct correlations with the boundaries.